One of the things we use Bohr models for is to try to determine what an atom would look like. But just as with any model, this is not really what the atom looks like, but it helps us to understand how it works, how it behaves, things like that. Just keep that in mind as we go through this tutorial. Here are the steps for drawing Bohr models. First, you need to make sure you have your periodic table. You're going to use that to identify the symbol, the atomic number, and the atomic mass for the element in question. From that, we're going to be able to calculate the pen numbers, the protons, electrons, and neutrons. Then we'll draw the model. We're going to draw it from the inside out, so from the nucleus to the first energy level, to the second energy level, to the third energy level. So you're moving away from the nucleus. And when we draw these Bohr models, we're going to use a P plus to represent protons. So we would write the number of protons followed by the P plus, or we would write P plus followed by the number of protons. Same with neutrons, except for we're going to use n to the 0. And then for electrons, we're going to use dots to represent electrons. We're going to place the electrons on each of the energy level, and we're going to pair them to make it easier for me to count when I'm grading it. Now, energy levels can only hold a specific number of electrons. So you have to remember that up to 2 electrons can be placed on the first energy level, and then up to 8 electrons can be placed on the second and third energy level. We will not do any Bohr models for elements higher than 20. I like to teach the ape-man mnemonic for determining the pen numbers. And the A, it stands for atomic number. And it equals the P, which is the proton number. This also equals E for electron number. Now, so here's the thing. Protons have a positive charge and electrons have a negative charge. And the reason the protons equals the electrons is because all of our atoms are going to be electrically neutral. That means they're going to have 0 charge. So if we have one positive, we have to have one negative to get that neutrality. All right, looking at man. M stands for mass number. We're going to get that from the atomic mass, round it to the nearest whole number. And we take mass number minus the atomic number, which remember that equaled the number of protons. And that is going to give us the number of neutrons. So there's our mnemonic, ape-man. And we talked about atoms being neutral, so having the same number of protons as electrons. So let's look at an example for sulfur. 16 is going to be the atomic number. If you look at your periodic table, it is labeled for you. And then the number at the bottom is our atomic mass. So we need to know this information in order to get our pen numbers. Alright, so we take, if we're looking for our pen numbers, protons is the atomic number. So that's 16. Electrons is the atomic number, or the number of protons, which is also 16. And the neutrons, we're going to take the atomic mass, which for sulfur we see on here is 3206. We're going to round it to the nearest whole number, which is 32. And then we're going to subtract from that the atomic number. So we're taking the bottom number, rounding it to the nearest whole number, and subtracting the top number from it. And that gives us 16. And that is how we calculate pen numbers. So let's have an example for a Bohr model. We're going to draw the Bohr model for argon. We want to calculate the pen numbers. First, after we have looked at our periodic table for the atomic number and the atomic mass, our number of protons is the atomic number, which is 18. According to Apeman, 8 equals P equals E. And then N is M minus A, and we've got 39.95. Remember, we're going to round this to the nearest whole number, so it's going to be 40, and then we're going to subtract this from it. So we take 40 and we subtract the 18, and that gives us 22 neutrons. So now that we have our pen numbers, we can do our Bohr model. In the nucleus, because we start from the nucleus and work our way out, in the nucleus we have protons, and there are 18 of them. There we have neutrons in the nucleus, and there is 22 of those. So we're going to fill the nucleus first. Now we're going to place electrons on the energy level. And remember, each energy level can only hold a certain number. We have a total of 18 that we need to fill. The first energy level can hold up to 2. 1, 2. And a quick note, it's almost easier to kind of keep track of them as you go. So we have 18 minus 2, so we have 16 left. Our second energy level can hold up to 8, and we're going to pair them now. So we have 1, 2, 3, 4, 5, 6, 7, 8. So looking at our numbers here, we're going to subtract that 8 from our original number, and we still have 8 left. And then our third energy level can hold up to 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. So when we subtract that final 8 from this 8, we have now used up all of our electrons. And you can double check by counting all the dots, and that the number of dots should equal the number of electrons. There is our Bohr model for argon. Be careful. If you look at Google or other websites, you're going to potentially see these done in a different manner. I will be grading your models based on the way I have taught you to complete them. So make sure you use this method. Another way to represent electrons in atoms is by using electron-dot structures. Now, electron-dot structures only uses the valence electron number. These are the electrons involved in bonding. And since these are the only electrons that determine chemical properties and behavior, these are the only electrons involved in bonding. So we are going to use the periodic table again to identify the symbol for the element and the valence electron number. Remember, these are the electrons in the outermost energy level, like mentioned, and they're identifiable by the group number. Once we've obtained that information, we're going to write the chemical symbol down, and then we're going to use dots to represent the electrons, and we're going to place them clockwise in the method shown in this map. So we would start here with 1, and then we place 2, and then we go to 3, and then 4, because it's very important that all 4 sides have 1 electron before we pair them up. So if we do it in this manner, then we will follow that rule. And then we would go to 5, 6, 7, and 8. You know, we're going to keep placing them until we run out of valence electron numbers. So let's practice. Alright, our example is gallium. So we need to find gallium on our periodic table. It's right here. That's our gallium. And we need to know what group number it's in. So if you have numbered your periodic table from the past, remember that this was 1A, 2A, 3A, 4A, and then 5A. I'm running out of room. 6A, 7A, and then 8A. Sorry about that, guys. I'm just running out of room there. So we know the valence electron number by looking at the group number. And the valence electron number for gallium is 3. That means I am going to use 3 dots in my model. So looking at here, there's 1, 2, and 3. And that is my electron dot structure for gallium. Your assignment will look like this. It's a PowerPoint, and you're just going to complete the PowerPoint and then save it and submit it. So in the nucleus, it's a text box. So you will just click in that box and type in the numbers of protons and neutrons. For the electrons, these guys you're going to place on the energy levels. Remember, the first energy level can hold up to 2. The second energy level can hold up to 8, and then the third energy level can hold up to 8. You're also going to use these for the electron dot structure. You're not going to use all of the electrons for majority of your models, but that's how you're going to do it. The end result should look something like this. Alright, make sure you send me your questions. Thank you for watching.